Let's consider the example of finding the volume using so-called cylindrical shells method. So in this method, we need to create the object. So we have to draw a region between these two curves and rotate this around this line. So let's try to draw all of them. So first of all, you should know that x minus x squared is going to be the parabola. Since the coefficient before the x squared is negative, it means that it's going to be a concave downward. So first of all, what I can do is I can take out the x from the brackets and I will have 1 minus x. So it means that it's going to have two roots. One is the x is equal to the 0. The second one is going to be x is equal to the 1. And I have some ideas about how to sketch it. So we know that this curve is going to touch the 0 and let's say 1. So let's say 1 is going to be somewhere here. And then it should look like this. So since this is the parabola, it should be like this. So this is the graph of this curve. And we know how to sketch this because we know that it is looking down because its coefficient before the x squared is negative. We know that it's two roots. It should cross the 0 and 1, and it will look like this. So the second one, x is equal to the 2, it's going to be a line where all the points have the x coordinate to be equal to the 2, right? So this is obviously is going to be the vertical line, right? So this line, x is equal to the 2, because any point here on this, along this line, is going to have x is equal to the 2. So x coordinate is equal to the 2. So we need to get this region, and we have to rotate this around this vertical line. So what does it mean? It means that we are going to have here the similar hill, right? So it's basically, it's a rotation. Whenever we rotate this, we're going to have this similar here. So I would like to, so what I have to do is we need to create a lot of cylindrical shells. So in order to try to understand what we're going to do, so let us do a couple of analysis. So here, so it doesn't matter how it works here. So this is the y, this is the x. So let's create one cylindrical shell. So what I have to do is I need to choose some point here on the x, right? Then we have to create this cylinder and the shell itself. So if you remember the formula to find the volume using the cylindrical shell, it was the integration of 2 pi multiplied to the radius multiplied to the height, and we have to integrate this with respect to the x, for example, where the x is going to change from some number to another number. So the radius, so the height, so let's talk about the height first of all. So the height, so let me draw this with a yellow one. So the height is going to be the y coordinate of the points along this curve, right? For example, I'm going to start creating the cylinders starting from here, for example, right? So at this point as well, the height is going to be the y coordinate. Or if I create the cylinder here, so the y coordinates are going to be always the height. So if the point has the x and y coordinate is going to be the height. So if I give you if I give you the x, tell me what's the y. So it's going to be y is going to be equal to the x minus x squared. So if you give me x, I'm going to tell you that the y is equal to this one. This is equal to the height of a cylinder at some point x. So another problem is we need to figure out what's going to be the radius, right? So the radius of this cylinder is this one. The radius of this cylinder is this one. This is not x, right? So x is here. The x is going to be this distance. This distance is equal to the x. So if this is the x, What about this distance? So since I know that this is going to be x is equal to the 2, so this distance is going to be 2 minus x. So the same as here. For example, if this point is going to be, for example, some x1, what does it mean? It means that the distance starting from here, from 0 until here, it's x1. Then this distance, which is the radius of this yellow cylinder, the radius is going to be equal to the 2 minus x at the point x. So now what we know what's the radius as well. So the radius is going to be 2 minus x at the point x. So this is the most important things we had to derive. The rest is really technical. So the x is going to change obviously from 0 to the 1, right? So if the x is equal to the 0, it means that the radius is going to be equal to the 2. If the x is equal to the 1, the radius is going to be equal to the 1. So let's do the integration. So we have to integrate this from 0 to the 1, 2 pi multiplied to the 2 minus x multiplied to the x minus x squared, and we have to integrate this with respect to the dx. So I'm going to take out the 2 pi out of the bracket, and I'm going to multiply, open up the brackets. It's going to be the integration from 0 to the 1, 2 pi. So the 2 multiplied to the x, it's 2x minus 2x squared minus x squared plus x cubed. So let me check this one more time. So it's going to be 2 multiplied to the x minus 2x squared minus x squared plus x cubed. So this is equal to, so I can, so this is actually 2x minus 3x squared plus x cubed. So I can just take the antiderivative. It's going to be 4 pi x squared over 2 minus, so the 3 multiplied to the 2, it's going to be 6 pi x in the power of 4 divided, 4 divided to the 4, because 3x squared, its integration is going to be 3x cubed over 3x cubed over 3 plus 2 pi multiplied to the x in the power of 4 divided to the 4, right? So x cubed, and its integration is x4 over 4. We have to put this from 0 to the 1. So please note that whenever we substitute the 0 to all the values of the x, we're going to have obviously 0. We just need to put the 1. It's going to be a 2 pi. If I put the 1 to here, it's going to be minus 2 pi. If I put the 0 here, so the plus pi over 2. So this 2 pi and this 2 pi with the minus are going to cancel, and we're going to have pi over 2. This is going to be the volume of this object, which we obtained by rotating this region around this line.